Welcome back to the deep dive. Today, we are pointing our instruments toward a mysterious valley in central Norway where the unidentified has been instrumentally verified for decades. Before we plunge into the specifics of this really strange mystery, a quick but crucial note. If you love these deep examinations of high strangeness backed by hard science, please make sure you follow us, Meet Deep Dives, on every platform where you get your audio content. And to all of you who already follow and share these discussions, thank you so much. Honestly, you're the reason we can keep peeling back these layers. So, we are talking about the Hessdalen Lights, or HL, a luminous phenomenon that is persistent, anomalous, and crucially, no longer just a rumor or, a ghost story. We have a stack of sources here that represent decades of scientific investigation into Norway's greatest geophysical puzzle.
That's right. Our mission today, really, is to move the Hessdalen Lights beyond that simple unidentified status. We have instrumental data gathered by automated stations, university researchers, physicists. Serious work. The goal is to synthesize this data to understand the complex, multi-stage geophysical engine that is, well, powering these lights. We're moving from what is it to how does the Earth make this?
And the findings are genuinely paradigm shifting, aren't they? We are not talking about distant stars or atmospheric reflections here. We've got confirmed radar tracking of physical, invisible objects moving at impossible speeds. We have measured radiant power output up to 19 kilowatts. That's enough power to run a small house, sustained right there in midair.
And perhaps most importantly, we have a definitive chemical fingerprint. Spectral analysis didn't just find expected atmospheric gases. It found silicon, titanium, and critically, its specific local element, scandium.
They do.
Yeah, along with helium. And this is definitive proof, really, that this phenomenon is tied directly to the unique rocks and the radioactive decay happening in that specific valley floor.
That is our objective, then. To piece together the valley battery, the dusty plasma, and these Coulomb crystals that seem to give birth to Norway's most enduring anomaly. Okay, let's unpack this. Let's start with the setting itself. We need to understand the geography, the history, what allowed this mystery to escalate. You really can't talk about the Hessdalen Lights without understanding the valley they inhabit, can you? It's not just some random location. Where exactly is this place, and why does the geography matter so much to the science behind it?
Right. Hessdalen is, well, it's a striking, relatively isolated valley. It's located in the central part of Norway. It runs about 12 to 15 kilometers north to south. It's rural, sparsely populated, and situated roughly 120 kilometers south of Trondheim. And that geographical isolation is important because it minimizes interference from, conventional sources like airports, city lights, even heavy vehicle traffic. It makes the observation scientifically cleaner.
So if you see a light in Hessdalen, the default explanation isn't likely to be a plane coming in for a landing.
Exactly. Much less likely. But the real story, the foundational ingredient for this entire recipe, it's in the ground itself. We have to look at the geology. The valley's composition is absolutely foundational to the mystery.
Okay, help us understand that foundational geology. What makes this valley unique from a mineral perspective?
Well, the bedrock here is highly varied, and critically, it's highly metalliferous. It contains specific metamorphic and igneous formations like gabbro, amphibolite, and pholites. And crucially, this area has a long, specific history of mining for different metals. Specifically, copper, zinc, and iron deposits have been mined there. This specific mineralogical makeup, this juxtaposition of different conductive metals and quartz-bearing rock, is the essential component that feeds and powers the leading scientific explanations for the phenomenon.
Ah, I see.
We're talking about an entire natural system built on conductivity and varying metallic compositions right next to each other.
So the Hessdalen Lights, HL, they're defined as unidentified, free-floating, anomalous, luminous phenomena. They appear day and night. But the most important part of that technical definition, it seems, is that their existence as a real physical anomaly is no longer in serious scientific doubt. It's a physical problem, not just perception.
Precisely. We are past the debate of if they exist. The research has really forced us to confront the question of how they exist and what combination of geology, chemistry, and frankly, extreme plasma physics is required to maintain them. Hashtag 1.2, the 1981-1984 surge.
Now, the lights have been an occasional local curiosity, apparently dating back to the 1930s, but something changed dramatically in the early 1980s that really forced the scientific world to pay attention. Let's talk about this flap.
Yeah, the flap. It refers to a dramatic, intense escalation in sightings that began in late 1981 and lasted intensely until about mid-1984. It was just an explosion of visible activity. Before this, sightings might have been anecdotal, maybe dismissed. After this, they were just undeniable.
And When you say intense, it sounds like it was pretty overwhelming for the community there. What kind of frequency are we talking about at the peak?
It was startling, really. Activity peaked at an astonishing 15 to 20 distinct sightings per week.
Per week.
Yeah.
Wow.
And if you consider the valley is sparsely populated, virtually every resident would have been seeing this several times a month, maybe even more often.
Yeah.
This wasn't just a handful of isolated reports. It was a persistent, highly frequent, localized, and very public event. It must have felt inescapable.
The resident accounts really give us a necessary human anchor to this scientific story, don't they? We read accounts like those from Age and Rut Mary Moe who described a burning fireball. This wasn't just some distant speck of light in the sky.
Absolutely not. The accounts detail lights descending close to houses, sometimes lingering, causing genuine alarm and disruption within the local community. I mean, imagine living in an isolated area and having these high-energy phenomena regularly floating near your windows, maybe even interacting with your environment.
Yeah, that's unsettling.
That intimacy of the sightings is what brought journalists, international attention, and eventually the initial scientific investigation.
But what's truly fascinating, and what any robust scientific model must explain, is the temporal mystery of the whole period. It didn't just stay at that peak level.
No, exactly. Just as rapidly as the activity started, it subsided after mid-1984.
Uh-huh.
It dropped back down to a steady, much lower baseline, about 10 to 20 sightings per year, which is still significant, but nothing like the flap.
Right.
So if the cause was merely a static feature of the geology, that frequency should be constant, or at least much more stable.
So the sharp rise and the sharp fall of the flat period suggest that while the fundamental geological engine might be static, the trigger that turns the engine on and off must be highly variable.
Precisely.
Hmm.
We need a dynamic trigger. Scientists suggest this could be maybe a period of increased temporary tectonic stress leading to microfractures in the rock. Or perhaps significant changes in the valley's hydrology, say, a peak in water flow, enhancing the conductivity of this proposed valley battery. The engine is there, but the environmental conditions required for ignition seem to come and go. Hashtag tag 1.3 typology of the lights, the complexity.
Okay, so we've established that the Hessdalen Lights are real, they fluctuate in frequency, and they're tied to the local area. But when researchers talk about HL, they seem to be referring to a family of phenomena, not just a single type of light source. Why is a clear typology, a classification, essential for the scientific investigation?
It's absolutely critical. We have to understand that HL is really a categorical label for multiple distinct phenomena. Trying to find one single explanation for all 5 types is probably a scientific dead end. I mean, the physics required to explain a brief high-altitude flash is entirely different from the physics needed to sustain a stable, structured light that hovers for an hour.
Right, that makes sense.
So we are effectively looking for a composite model that can account for different manifestations of the same underlying energy system.
Okay, let's go through the 5 categories established by the researchers, starting with what might be the simplest manifestation.
Right, category 1 is flashes. These are very short-lived, we're talking seconds, and typically appear high altitude, often near the mountaintops. They're usually intense white or blue-white. These are the phenomena that lend themselves best to that piezoelectric spark theory we'll discuss later, like geological lightning almost.
Okay. Then category 2 is orbs. This is the iconic classic Hessdalen light that everyone visualizes, right? The stable floating light.
Exactly. They range from yellow to white, but their defining feature is the duration. They can last anywhere from seconds to over an hour.
An hour.
Yes, over an hour.
Yeah.
Remaining stationary, maybe swaying slowly or drifting gently across the valley. To sustain a stable, high-energy orb for 60 minutes requires a continuous, substantial power source that immediately rules out many transient explanations, like simple ball lightning.
Okay, moving up in complexity then.
Category 3 is clusters. These are more structurally complex. They often appear as doublets or multiple grouped lights moving in tandem. They are typically yellow, often with a distinctive red flashing top component, and they tend to drift slowly. The fact that they move as a single cohesive system suggests some kind of dynamic interaction or maybe a shared field structure holding them together.
Interesting. And category 4 is geometrics. This is where the physics truly challenges our assumptions, isn't it?
It really does. These are structured, solid-like shapes. Reports include perfect triangles, rectangles, or even an observed dark black object with a light component attached to it.
Wow.
These geometric forms last minutes or less, usually, but their very existence points directly to a structured, ordered state of matter, which is the key piece of evidence for the Coulomb crystal model we'll get into.
Okay. And finally,
Finally, category 5 is kinetics. This category is defined purely by motion. These are the phenomena that exhibit extreme, non-ballistic speeds, sometimes clocked at up to 30,000 kilometers per hour.
30,000.
30,000 kilometers per hour. This speed and the highly erratic, non-inertial movement, instant stops, sharp turns, this is the category that most definitively rules out conventional physics, whether it be aircraft, birds, or weather balloons. Nothing we know behaves like that.
The transition from a simple flash to a structured geometric object to something moving at Mach 25.
Yeah.
Yeah, it shows we're dealing with a complex physical system operating under different energetic and structural constraints. This demands instrumental confirmation, which brings us to the first major research project. The sheer volume and variety of sightings during that flat period, it demanded a scientific response, didn't it? Which led to the early attempts to capture hard data. Hashtag 2.1 Project Hessdalen, 1983-1985.
Absolutely. Project Hessdalen was born directly out of that 1981-1984 surge. It was initially a kind of grassroots collaborative effort, started by students, engineers, and journalists from organizations like UFO Norge and UFOs Verge. They recognized that the only way to settle the issue was objective measurement, get instruments on site.
The initial primary field investigation, conducted in early 1984, was remarkably short, only about 5 weeks long. But it yielded foundational results that still underpin the research today, right?
It was an incredible burst of data collection in that short time. They logged 188 reports during that period and were able to instrumentally confirm 53 distinct light observations.
53 confirmed.
53 confirmed with instruments. That success rate in such a short window immediately validated the phenomenon. It wasn't about subjective interpretation anymore. It was about confirmed measurement.
Let's dive into the hard data they gathered in '84. Starting with the radar, which provided the first really undeniable proof of physical objects moving impossibly fast.
Yes, they deployed an Atlas 2000 radar system. And in one of the landmark confirmations, the radar tracked a light moving at an estimated speed of 8,500 meters per second.
8,500 per second.
Per second. To put that in context, that is roughly Mach 25. Nothing conventional moves like that, especially not near the ground. This was the first hard data proving that these are physical, radar-reflective objects capable of extreme non-ballistic speeds. It immediately shifted the conversation from unexplained aerial phenomenon to a complex, extreme physics problem.
They also got some early spectral analysis. It was weak, apparently, but it provided a key hint toward the composition of the light source.
Yes, they obtained a weak, but importantly, a continuous spectrum. This is a crucial distinction.
Explain that again. Why is continuous important?
Okay, so a line spectrum, like you'd see from an aurora or a neon sign, means specific excited gases are glowing at specific frequencies, specific colors. A continuous spectrum suggests the light source is either an incandescent solid, a liquid, or a very high density, very hot plasma. Something glowing because it's hot, emitting across a broad range of frequencies.
Like a filament in a light bulb.
Sort of, yeah. Or the surface of a star. It points away from simple gas discharges and towards something solid-like, or at least particulate, that is glowing due to heat.
And their magnetometer registered about a 40% correlation between the confirmed lights and simultaneous magnetic pulsations.
Right, which immediately links the phenomenon to the valley's local geomagnetic environment, supporting the idea of a large, localized electrical system at play.
All of this was groundbreaking, but the finding that perhaps most surprised the researchers and continues to challenge the simplest physical models was the laser interaction test.
Ah, yes, the laser test. That was remarkable.
Walk us through that incredible moment. How did the methodology work, and what happened when they aimed the laser at the light?
So the researchers were tracking a stationary blinking light, likely one of the Category 2 orbs. They aimed a standard low-power laser beam directly at it. The hypothesis was simple observation. Does anything change? And the result was, well, profound. The light immediately stopped its current blinking sequence and adopted a new, different flashing pattern.
It just changed its rhythm instantly.
Instantly. And it maintained that new pattern. It held that new flashing sequence for exactly the duration of the laser contact.
And the moment the laser was off.
The moment the laser was removed, the light reverted back to its original sequence. And here's the essential point for validating the data. They successfully repeated this test 8 out of 9 times with the same result.
8 out of 9 times. That level of repeatable, instantaneous, and sustained response to an external stimulus, that's what throws simple physics models into chaos, isn't it? If it's just random gas, it shouldn't react like that so consistently.
It creates immense difficulty for an easy physical explanation. Is it simply the laser energy physically disrupting the plasma's internal oscillation? Maybe. Or does a highly coherent, structured plasma formation, like the Coulomb crystal idea, react to a sudden input of external energy by stabilizing or reorganizing its structure in a controlled, predictable way?
Hmm.
It forces us to entertain questions of complexity that, frankly, border on the conscious or intelligent, even if it's just physics we don't fully grasp yet.
It's a very surprising data point, as they noted back then. But the investigation also included important negative data that helped narrow the field of possible explanations.
Right. They deployed a seismograph specifically to test the simple earthquake light equal theory, which suggests electrical discharges caused by major tectonic stress. The instrument recorded virtually no local seismic activity during the entire investigation period.
So no big quakes were happening.
Exactly. While rock stress might still be the ultimate trigger, the simplest model requiring major seismic fault lines releasing energy was weakened. The stress must be microscale or localized, or perhaps caused by non-seismic forces like hydrology changes. Hashtag tag 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 2.2, the automated monitoring, AMS.
The initial project Hessdalen was short-lived. It ran out of resources after the flap died down, but the commitment to the science wasn't. The research entered a new, permanent phase in 1998 with the establishment of the Hessdalen Automatic Measurement Station, or AMS.
Yes, known affectionately as the blue box. The AMS represents the transition from short, intense expeditions to continuous modern monitoring. It's an automated container, basically, strategically placed on a hillside overlooking the main valley. This provides continuous data collection 204/7, regardless of human presence, minimizing observer bias, and crucially collecting statistics even during low activity periods.
What kind of advanced instrumentation does this permanent station house? It must be ensuring pretty comprehensive surveillance.
Oh yeah, it's significantly more comprehensive than the 1984 kit. It includes high-resolution color and black and white TV cameras capable of capturing events even in near darkness. It has a sophisticated magnetometer array for measuring magnetic fluctuations in 3 axes, and updated radar capabilities for tracking fast-moving and, importantly, non-luminous objects.
Non-luminous, we'll come back to that.
Yes. This continuous, often open-access stream of data allows both the citizen science nonprofit Project Hessdalen and academic collaborators to gather and analyze trends over decades now.
And this ongoing collaboration brings in serious international academic muscle, which is important.
Yes, it really confirms the scientific gravity of the phenomena. They collaborate closely with Østfold University College in Norway, which manages the physical station, and the Italian National Research Council, CNR, through programs like MBLA. The transition from a local short-term expedition to a permanent, internationally recognized collaboration with major institutions like CNR speaks volumes about the verified, persistent reality of the lights.
Right.
The scientists involved are not fringe characters. They are mainstream physicists and geologists dedicating serious time and resources to this puzzle.
Okay, the instrumental data gathered over these decades provides the essential breakthroughs. We need to go into extensive detail now on the chemical signature, what you called the Rosetta Stone, and the physics of the object itself, which seems to challenge our basic understanding of matter.
Let's start with the spectral analysis, because it tells us what the light is composed of and definitively anchors the phenomenon to the valley floor. As we mentioned, the first crucial finding is that consistent, continuous optical spectrum.
Let's pause here again, because that distinction is really key for the listener, I think. If I'm not a physicist, why is a continuous spectrum so important, and how is it different from a line spectrum? Remind us.
Okay, think of it this way. When you look at a rainbow, you see a continuous spread of colors, right? Red flows into orange, into yellow, and so on. That's energy emitted by a source that is solid or highly dense, and it's glowing because it's hot, like the element in your toaster or the surface of the sun. That's a continuous spectrum. A line spectrum, however, looks more like a barcode. You see discrete, bright lines of specific colors against a dark background. That happens when specific diffuse gases are excited by electricity, like the low-pressure gas in a neon sign. Each gas has its own unique barcode.
Got it. So the fact that the Hessdalen lights show a continuous spectrum strongly implies that they are not just diffuse excited air. Something solid-like is incandescent, glowing hot.
Precisely. It strongly suggests the light is coming from matter that is either a solid, maybe a liquid, or a very high-density, high-temperature plasma. Something solid or particulate is burning or glowing intensely.
And when scientists analyze the specific lines superimposed on that continuous background spectrum, they find a chemical fingerprint that ties the light directly to the ground beneath it. What elements are the fuel?
Right, so we find the expected atmospheric elements, hydrogen, oxygen, nitrogen, because, well, the phenomenon is happening in the air and is effectively burning air interacting with it. But then we get the definitive geological markers. Silicon Si is consistently present, which is the first powerful clue that the phenomenon involves silicates, meaning atmospheric dust uplifted from the valley floor, rocks and soil.
Okay, silicon makes sense. And what about the definitive metals that point specifically to this region?
Well, we find titanium tite, which is pretty common in many soil samples. But the most significant finding, the real smoking gun, is scandium.
Scandium.
Scandium. It's a rare earth element, it's very reactive, and critically it is found specifically in this geological region of Scandinavia, often associated with certain mineral deposits. Its consistent detection in the light spectrum is definitive evidence. The light is intrinsically linked to the unique local mineralogy. You likely couldn't create a Hessdalen light in, say, Ohio or the Sahara, because the fuel, this scandium-rich dust, isn't there.
That is extremely specific. Okay, so if scandium-rich dust is the fuel, what acts as the constant localized ionizer or ignition source? Where does the initial energy come from to light it up?
This is where the radiology of the valley comes in, and it completes the chemical puzzle beautifully. The spectral data also reports the presence of helium-He emission lines. Now, helium itself is generally benign, but its presence here is the fingerprint of a radiological process. The Hessdalen Valley contains natural deposits of heavy elements like uranium and thorium. When these elements radioactively decay over long periods, one of the products they produce is radon gas.
And radon gas seeps up from the ground, right?
Exactly. Radon seeps out of the bedrock and into the air. Now, when radon itself decays, it emits high-energy alpha particles. And chemically, alpha particles are helium nuclei.
Ah, so the helium they detect is actually alpha particles from radon decay.
That's the strong implication. These alpha particles are the constant ionizer, constantly bombarding the atmospheric dusts and gases in the valley air, knocking electrons off atoms and creating a sea of charged particles, ions, and electrons.
I understand now. Wow. Okay, so the spectral data provides the entire system. The fuel is the scandium-bearing dust, and the ionizer is the steady stream of alpha particles from local radon decay. This links geology, chemistry, and radiation into one physical process, making it a truly unique local phenomenon that's quite elegant, actually. Hashtag tag 3.2 radar, energetics, and physicality.
It really is.
Yeah.
But beyond the chemistry, the physical behavior of the lights is where the physics gets incredibly challenging. Let's start with the most perplexing instrumental finding, which researchers have dubbed the invisible anomaly.
The invisible anomaly, what does that mean?
This data point is arguably the most powerful evidence against simplistic theories. Scientists have repeatedly recorded an object producing a strong radar reflection, indicating a solid physical presence, yet it remains non-luminous. It is, as they say, something moving without being seen by a light.
So the phenomenon can exist in a physical, structured state without being incandescent, without glowing.
Precisely. This proves the entity is a physical, structured, radar-reflective object that is not necessarily luminous all the time. This single data point is fatal to hypotheses like simple ball lightning or minor static discharges, which must be luminous to exist.
Why?
It forces us to accept that there is a physical entity, likely highly structured matter, existing in a dark state, which strongly supports these advanced Coulomb crystal models we keep mentioning.
And this structured object is not low energy. What did Dr. Massimo Teodoranti's energetic analysis show about the sheer power required to sustain this anomaly when it is luminous?
The energy required is immense and continuous, ruling out short-lived processes. Teodoranti's analysis shows the peak radiant power output can reach up to 19 kilowatts.
19 kilowatts. Let's put that figure into perspective for people listening. How much power is that, really?
Well, a typical North American household might use maybe between 5 and 10 kilowatts total power continuously on average. This single light phenomenon is emitting enough radiant energy, just light and heat, to run 2 or 3 small homes, sustained right there in midair.
That figure is a crucial constraint then. It instantly rules out low-energy explanations like swamp gas, misidentified car headlights, bioluminescence, even minor static discharges. You need a massive, continuous local power source.
Exactly, which strongly points toward the Valley battery idea we'll get to.
Yeah.
We're talking about a natural energy transfer mechanism that is currently outside our conventional understanding of atmospheric physics.
What about the structure of the light itself? You mentioned it wasn't just a fuzzy ball. If it were just a ball of hot gas, how would the light intensity look?
Right. If it were an ideal diffuse gas plasma, it would typically be brightest at the core and gradually fade out toward the edges. It would look fuzzy and spherical, like a typical fireball maybe.
Hmm.
However, Teodorani's analysis of the light intensity distribution, looking at the images carefully, found the orbs often showed a flat-topped, steep-sided profile.
Flat-topped and steep-sided. That suggests uniform illumination up to a clearly defined boundary, almost like a solid object that's lit up.
Yes, it is physically consistent with a uniformly illuminated solid-like ball. This corroborates the idea that the object is structured matter, held in a highly defined shape, rather than simply diffuse gas.
Hmm.
The shape suggests external forces, specifically electromagnetic fields, are organizing the matter into a somewhat rigid form.
This physicality is supported by their dynamic behavior too, right? They form clusters, suggesting cohesive units, and they've been seen to eject smaller light balls.
Yes, indicating internal instability or maybe reproductive processes, if you want to be speculative. And we return to the traces they leave behind. Researchers have found evidence of the possible deposition of metallic particles, actual physical residue left on the ground after sightings.
Metallic particles? Like the scandium, maybe?
Possibly, or other components. And tying back to the spectral data and the ionizer, they measured a significantly higher level of radioactivity on rocks near where a large light ball was observed hovering.
Which supports the radon dialpha particle ionizer theory.
Exactly. It all starts to fit together. The data paints a detailed picture. A powerful, structured, energetic object chemically and radiologically tied to its specific location.
This is why the three leading theories are necessary, isn't it? No single theory can explain all of these disparate facts on its own. Which brings us to the unified geophysical model.
Right. The scientific consensus, at least among the most dedicated research groups working on this, is that the three leading hypotheses are not mutually exclusive. They're seen as complementary components required to explain the composite nature of the lights. We need, it seems, three elements working in tandem: a massive power source, a variable trigger, and a unique medium fuel capable of forming a structured object.
Let's start with the immense continuous power required, that 19 kilowatts of radiant output we talked about. Jader Minori proposed the Valley battery model. How does the unique geology of Hessdalen Valley potentially act as a giant natural battery?
This model leverages the specific mine geology we discussed earlier. It's theorized as a large-scale electrochemical process, much like a simple zinc-carbon battery you might have in a flashlight, but using entire geological strata. To create a battery, you need two dissimilar conductive electrodes separated by an electrolyte. Right.
Okay, so what are the electrodes on this geological scale?
The anode, the negative electrode, is hypothesized to be the zinc and iron-rich rocks, which are found predominantly on the western side of the valley. The cathode, the positive electrode, is thought to be the copper-rich rocks, located mainly on the eastern side. Different metals in close proximity naturally generate a differential electrical potential, a voltage difference.
And the electrolyte, the substance that allows the charge to flow between these rock layers.
That would be the water of the river Hesja, which flows right between these two metallic strata. The river water acts as the electrolyte, and its conductivity is thought to be dramatically enhanced by the presence of sulfuric acid, which is a natural consequence of water drainage, leaching through the old abandoned copper and iron sulfide mines in the area. Sulfides plus water plus air makes sulfuric acid.
So the mining actually contributes to the battery's efficiency.
Potentially, yes. This differential potential creates a natural current flow through the valley's crust and generates the large-scale electromagnetic field lines that researchers believe correlate with the light's appearances and movements.
This provides a plausible mechanism for generating continuous energy, and the geological surveys seem to support the foundation of this idea.
They do. A recent VLF, Very Low Frequency Radio survey, I think in 2024, specifically confirmed the existence of highly electrical conductors in the ground and mapped out the massive mineral deposits necessary for this large-scale electrochemical circulation. It proved the plumbing and the materials for the battery are indeed present.
But wait a second, if the system is potentially powering 19 kilowatts of energy output, how can critics say the generated voltage is likely only maybe 1 volt? Doesn't that low voltage immediately invalidate the idea that this battery is the sole power source?
That is the essential criticism, and it highlights exactly why the three models must be unified, why they need to work together. Critics point out, quite rightly, that the generated voltage from the electrochemical differential itself is probably very low, perhaps only 1 volt, maybe less. Now, while the current circulating through the large mass of conductive rock might be substantial, remember, power equals voltage x current, that low voltage combined with the great distance between the electrodes means the battery is probably insufficient on its own to explain the intense, sudden breakdown of the air required for the phenomenon to start. It can't easily make a spark jump across the air.
Okay, so the Valley battery provides the massive, continuous energy field or current necessary to sustain a long-duration orb once it's formed, but it needs an external, variable, high-voltage spark to kind of jumpstart the process, to initiate the discharge.
Precisely. It provides the low voltage, high current potential, the background energy, but likely not the high voltage ignition required to create the first plasma formation. And this leads us directly to the trigger mechanism.
Hypothesis 2 acts as that necessary spark piezoelectricity. This is often linked to the simple earthquake light equal theory, although, as we said, large seismic activity is rare here.
Right. This model focuses on the abundance of quartz-bearing rocks throughout the valley. The piezoelectric effect is a fundamental property of certain crystalline materials, like quartz. When these crystals are subjected to mechanical stress, squeezed or deformed, they generate and release an intense electric charge.
What's the mechanism for getting that stress if it's not a major earthquake shaking the ground?
It's attributed to something called fractoemission. Think small, constant, often undetectable tectonic pressure or microstrain, like subtle shifting underground or expansion and contraction due to temperature changes, or even changes in water pressure in rock pores. This causes microfractures in the quartz crystals within the rocks. This fracturing builds up intense charge densities locally. When this charge reaches a threshold and is rapidly released, it creates a powerful electrical discharge, a spark.
So it's like scraping styrofoam, but on a geological scale, releasing a burst of electrons that ionize the air locally and produce a sudden flash of light. This sounds like it perfectly explains the shortest-lived phenomena, those high-altitude Category 1 flashes.
It does. It provides the sudden, high-voltage spark that the Valley battery model lacked. The piezoelectric effect is very good at generating high voltage, but typically low current, making it perfect for instantaneous flashes and discharges.
But we noted the weakness earlier. It seems to only explain the flash. It can't really explain the long-duration orbs that last an hour, or the complex geometric shapes.
Correct. And we must remember the negative data. The lack of significant recorded seismic activity correlating with most sightings. While microfractures due to other stresses are still possible, this model is clearly insufficient as a unified theory. It likely acts as one of the potential ignition mechanisms for the entire system, converting latent geological stress into an electrical discharge that then taps into the larger energy field.
Okay, so if we have the power, the battery, and the spark, piezoelectricity, we need the actual stuff that the light is made of, the medium and the fuel. This is the domain of Paiva and Taft's model, the dusty plasma, which culminates in this idea of a macroscopic Coulomb crystal. This model has to explain the scandium, the helium, the geometric shapes, and the invisible anomaly all at once. That's a tall order.
It is, but this is arguably the most compelling component because it synthesizes almost all the hard observational data. Let's walk through the exact steps of formation they propose.
Okay, step 1, source and ionizer. Lay it out again.
As we covered, the valley contains uranium and thorium deposits. These naturally decay, producing radon gas. This radon gas continually seeps out of the bedrock into the valley air. The radon decay process emits high-energy alpha particles, which are helium nuclei. These particles are the constant, ever-present ionizer bombarding the ambient air, knocking electrons off atoms and creating a background sea of charged particles, ions, and free electrons.
Okay, got the ionizer. Step 2, fuel.
This energetic sea of charged particles is constantly colliding with the atmospheric dust present in the valley air. We know from the spectra that this dust is rich in silicon titanium and that unique, localized element, scandium.
So we have charged air, plasma ions and electrons, and we have electrically charged dust particles all confined within the electromagnetic environment provided by the Valley battery's background field.
Step 3. The result, dusty plasma. Exactly. This mixture creates what physicists call a dusty plasma. Now, plasma itself is the fourth state of matter-ionized gas, but when you introduce micron-sized solid dust particles into that plasma, the physics changes dramatically. The dust particles become heavily charged, sometimes accumulating thousands of excess electrons, making them strongly negative.
Why don't these heavily charged dust particles simply repel each other violently and dissipate like normal charged particles would?
This is the key insight of the model. under the specific, sustained, low voltage, but potentially high current electromagnetic conditions proposed for the valley, the field generated by the valley battery. These charged dust particles can actually self-organize. The strong, short-range electrostatic repulsion between the dust particles is counteracted and confined by the weaker, long-range overall electric field of the valley. This balance of forces can apparently force the heavily charged dust particles into an incredibly ordered, crystal-like structure known as a macroscopic Coulomb crystal.
A Coulomb crystal. That sounds exotic. It's essentially a structured physical lattice of charged dust particles, held rigid or semi-rigid by external electrical forces.
That's the idea. Think of it like ions forming a crystal lattice in a salt crystal. But here it's charged dust particles forming a much larger lattice suspended in the air, held together by electromagnetic forces instead of chemical bonds.
Okay, help us understand why this physical structure, this Coulomb crystal, solves all the hardest data points we've discussed.
All right. First, it perfectly explains the geometric shapes, category 4. A crystal lattice is inherently structured. It naturally forms rigid, defined shapes like cubes, hexagons, or spheres, depending on the forces. This explains why the lights can look solid-like and have those flat-topped profiles. It's not a diffuse gas ball. Second, it explains the chemical composition, the scandium and helium. It's literally built from the ionized scandium-rich dust from the fuel, and it's sustained and ionized by the energy input, including the bombardment by helium nuclei, alpha particles.
Okay, shapes and chemistry covered. And most dramatically, it solves the mystery of the invisible anomaly, the radar reflective object that isn't glowing.
Absolutely. A Coulomb crystal is a physical object, a lattice made of actual mass, even if it's just microscopic dust particles. Therefore, it would be highly radar reflective. Now, if the energy supplied by the valley battery fluctuates or the piezoelectric spark fades, the crystal structure itself might persist for some time in a dark, state, physical, structured radar reflective, but not currently hot enough to be incandescently luminous.
So it can exist unseen.
Exactly. Why invent exotic alien stealth technology when the required physics, a structured, potentially non-luminous dusty plasma crystal, is plausibly explained by the known local geology and atmospheric conditions?
The unification is really quite stunning when you lay it out like that. The valley battery provides the continuous current and the confining field, the engine. Piezoelectric stress provides the occasional high-voltage spark, the trigger. And the unique radon-ionized, scandium-rich dust provides the matter that gets structured into the Coulomb crystal, the fuel and medium.
That's the integrated picture. This composite model covers almost every single major piece of observational and instrumental data gathered in the last 40 years.
Even with this robust, unified model emerging, we should pause briefly just to definitively rule out the obvious, mundane explanations that initially dominated the conversation decades ago. The instrumental data has to stand firm against simple misidentification, right? Hashtag 5.1, ruling out the mundane.
Oh, absolutely. Decades of instrumental data radar tracks, spectral analysis, energetic measurements have conclusively dismissed conventional misidentification for the core phenomenon. These are not merely subjective visual reports anymore. These are objective measurements of something unusual.
Let's just quickly reiterate why things like aircraft or natural processes like meteors are ruled out by the extreme speeds and behaviors.
Right. The associated objects, particularly Category 5, move at speeds up to 30,000 kilometers per hour, which is hypervelocity, far beyond any aircraft. Furthermore, these objects can hover silently for extended periods, sometimes observed moving below the treetops, perform sharp right-angle turns without slowing, and accelerate almost instantly. That rules out planes, helicopters, balloons, drones, conventional ones anyway, meteors, and standard atmospheric phenomena like meteorological reflections or mirages.
And what about ball lightning? It's often the default explanation people reach for whenever they hear floating orb of light.
Ball lightning simply cannot account for the Hessdalen data, particularly the persistent orbs and structured lights. Ball lightning, if it exists as typically described, is exceedingly rare, usually very short-lived, seconds, maybe a minute at most, and generally considered low energy compared to what's measured here. It certainly doesn't possess a 19 kilowatt continuous radiant output, last for over an hour, appear with such high frequency in one specific localized area, or, critically, display the internal geometric structures observed by researchers in Hessdalen. The physics of a sustained, structured, dusty plasma is entirely different from theories about transient ball lightning. Hashtag 5.2, the ufological and paracognitive hypotheses.
Okay, so once conventional explanations fail conclusively based on the data, the discussion naturally drifts toward the more exotic, including the extraterrestrial. The ufological interpretation attributes the extreme speeds, the erratic motion, and that invisibility to intelligent extraterrestrial activity probes or drones, perhaps.
Yes. This interpretation arises primarily from the Category 5 kinetics data, the extreme speeds and maneuvers, and that baffling invisible anomaly. The observed speeds and maneuvers appear to defy inertial physics as we understand them for conventional craft, leading some to the conclusion of directed intelligent movement.
But the scientific counterpoint, rooted in the plasma physics we've discussed, is actually pretty compelling, isn't it? The perceived intelligent movement could be plausibly explained by the complex physics of these plasma structures themselves.
Exactly. A highly charged, structured Coulomb crystal floating within the valley's specific and complex electromagnetic field, which is constantly fluctuating due to the valley battery current, atmospheric changes, etc., will react dynamically and perhaps unpredictably to us. It's likely reacting passively to the subtle changes in the surrounding EM environment. The movement seems complex, maybe even purposeful, but it might just be complex physics, not necessarily conscious piloting.
And what about the laser reactivity? That felt so intentional, changing its blinking pattern only when illuminated by the laser 8 out of 9 times.
The scientific counterpoint to the intelligent response idea is that the laser test, while dramatic, could be a predictable physical disruption of a high-energy structured plasma. You are introducing a highly coherent beam of energy into what might be a delicate, self-organized physical entity. It's almost expected that this would alter the plasma's internal energy balance and oscillation modes, causing it to change its blinking pattern until the external stimulus, the laser, is removed.
So it's like poking a complex electrical circuit and seeing it react in a repeatable way.
Kinda, yeah. It could be seen as a highly sophisticated electrical feedback loop inherent in the structure, not necessarily a conscious decision to communicate, although admittedly the consistency is striking.
But there is a final, even more complex philosophical question raised by some of the researchers themselves, specifically Dr. Massimo Teodrani, who did the energy calculations. This seems motivated by the most challenging data points: the perfect triangles, the structures, and that sustained responsive interactivity.
This is where we get to the profound philosophical leap, moving beyond testable physics for now. The question is, does this phenomenon, though fundamentally initiated by geology and radiation, possess its own form of conscious or intelligent life? Dr. Teodrani and others explore whether plasma coherence, particularly in a highly structured state like a Coulomb crystal, could potentially represent a previously unrecognized form of conscious life, or at least a self-organizing system operating at such a high level of complexity that it mimics consciousness or intelligence.
That is truly boundary-pushing stuff. It asks us to maybe redefine the very conditions required for something like life or self-awareness.
It is absolutely not a testable scientific theory in its current form. It's more of a philosophical question born from the failure of current physics to neatly explain every single observed detail, especially the interactivity and complex structures. It highlights the truly paradigm-challenging nature of the Hessdalen Lights. The phenomenon pushes the definition of a complex physical system so far that its behavior at times appears almost indistinguishable from intentional, intelligent action. Hashtag outro. Hashtag tag 5.3 synthesis and current status.
So let's try and bring all this together. The Hessdalen Lights are real. They're definitely a composite phenomenon with multiple types, and they are chemically, radiologically, and electrically tied to this specific valley in Norway. That much seems certain.
Yes, and the unified geophysical model, the valley battery providing the power, piezoelectric stress providing the high-voltage shutter, and radon-ionized scandium-rich dust forming a structured, macroscopic Coulomb crystal as the resulting entity, is the most plausible, data-driven explanation we have today. It really does account for the speed, the structure, the composition, the energy, even the invisibility.
The mystery, therefore, endures not because of a lack of data, surprisingly, but almost because the data we have is so robust and so fundamentally strange that it continues to challenge our current understanding of plasma physics, material science, and geological energy generation.
And frustratingly, the primary barrier to a complete predictive solution isn't really intellectual anymore. It seems to be purely practical. A lack of stable, long-term funding for the highly sophisticated research. More sensors, better modeling necessary to fully map, model, and predict the Coulomb crystal dynamics in this unique, natural, high-energy environment.
They need more resources to really nail it down. Hashtag TechShag 5.4 broader implications. So what?
Exactly.
Why does solving this specific mystery in one isolated Norwegian valley matter globally? What are the broader implications for science at large?
Well, Hessdalen is effectively a unique natural laboratory. For plasma physics, it's an incredible opportunity to study complex states of matter, like dusty plasma and Coulomb crystals, sustained naturally outside of a controlled lab environment. We might be witnessing natural sustained processes that are almost impossible, or at least incredibly difficult and expensive, to replicate artificially in a terrestrial laboratory for such durations and energies.
And for geophysics and energy, understanding the large-scale valley battery mechanism, how the Earth naturally generates and transfers this kind of immense continuous energy locally, that could lead to massive insights, couldn't it?
Yes. Researchers involved have openly suggested that understanding this specific geological energy conversion process could potentially lead to the discovery of highly efficient, completely novel mechanisms for clean energy transfer and generation, tapping directly into geological potentials.
So today's geophysical mystery could indeed be tomorrow's energy technology.
It's not impossible. It's certainly a motivation for continued study.
The Hessdalen Lights force us to rethink the energetic and structural limits of natural physical systems. We really encourage you, the listener, to reflect on that scientific frontier.
It forces us to ask, how far can complex natural systems evolve into self-organizing structures before they start operating in ways we currently only attribute to advanced technology or even life itself? If a self-sustaining structured lattice of charged dust, powered by the Earth's geology and radiation, can form geometric shapes and respond to external stimuli, well, what does that mean for our definition of an entity or even complexity bordering on sentience?
That is a fascinating and perhaps slightly unnerving question to leave you with, one that lies right on the boundary between physics and philosophy. A huge thank you again to everyone who supports the deep dive and follows us on all platforms. If you found this discussion of the Valley Battery, the scandium dust, and the invisible Coulomb crystals illuminating, please share this deep dive with someone else who loves a good, hard scientific mystery. Remember to follow us GL Deep Dives on every platform where you get your audio content.
As the Project Hessdalen researchers often maintain, today's mystery may be tomorrow's technology. We hope you keep exploring the unknown with us.
Until the next deep dive, keep digging.